As the world outside settles into its evening rhythm, I invite you to do the same. Find a comfortable space, let your shoulders relax, and take a slow, deep breath. Wherever you are in this beautiful world, and I would love for you to share your corner of it in the comments below. To feel our shared connection, know that you are part of a grand cosmic story. This story isn't a distant fantasy or a complex equation on a blackboard. It is the very foundation of your reality. The quantum realm is the silent, invisible engine that shapes every atom in the chair you're sitting on, every molecule of air you just inhaled, and even the very thoughts flickering through your mind right now. Tonight, let's peel back the curtain of the ordinary and explore a universe where the impossible becomes inevitable, where logic bends, and where science and poetic wonder become one. Think of the world you see as a beautifully woven tapestry. You admire the colors, the patterns, the story it tells. But what if you could look closer, so close that you could see the individual threads? And what if you discovered that each thread wasn't just one color, but every possible color at once, only choosing its final hue the very moment you looked at it? That, in essence, is our destination. The quantum realm is the loom upon which our reality is woven. It is a place of pure potential, a shimmering sea of possibilities where particles defy the logic we hold so dear. Here, an electron can be in multiple places at once. A particle can tunnel through a solid wall as if it were a ghost. And two objects can be linked across the universe, mirroring each other's actions instantaneously. This isn't science fiction. It is the fundamental, verified truth of our existence. To grasp the nature of this realm, let's start with a simple thought experiment. Picture a coin, not in your hand, but spinning in the air, captured in a state of pure motion. Before it lands, is it heads or tails? In our everyday world, we'd say it's one or the other. We just don't know which yet. But in the quantum realm, the answer is far more profound. It is both. It exists in a state of probability, a perfect blend of heads and tails simultaneously. Only when you reach out to catch it, when you observe it, does it choose a side and become the definite reality you see. This is the strange and beautiful logic that governs the universe on its most intimate scale. This world of probabilities isn't happening in a distant galaxy. It's happening within you right now. The atoms that make up your body, the photons of light from your screen that are hitting your eyes, all operate by these bizarre rules. This is a reality where particles can also behave like waves, spreading out like ripples in a pond. It's a world where the act of looking, of measuring, doesn't just reveal what's there, it actively shapes what is there. It's so profoundly strange that even the great Albert Einstein was deeply unsettled by it, famously doubting its completeness. Yet, despite its strangeness, this is the hidden engine of our cosmos. It is the silent, powerful current flowing beneath the surface of our perception, reminding us that the universe is not just stranger than we imagine, but stranger than we can imagine. Just when we think we might be getting a handle on these quantum rules, nature reveals it has a few more tricks up its sleeve. It loves to remind us that our playbook is just a first draft. In January of 2025, in a lab at Brown University, physicists made a discovery that sent ripples through the scientific community. They found something called fractional excitons. Now, an exciton is already a curious thing. It's a sort of temporary particle formed when light excites an electron, leaving a hole behind, and the two dance together for a moment. But a fractional exciton? This was something new. It was a particle that seemed to be only a fraction of a known entity, blurring the lines between the categories we've so carefully created. It's as if you met a person who wasn't just introverted or extroverted, but somehow a distinct, stable blend of both at the same time. A new category of personality altogether. These fractional excitons defy our established quantum rules. It's as if nature itself decided to rewrite a page of its own code, showing us that the building blocks of reality are more fluid, more creative, and more complex than we ever thought possible. Discoveries like this are a beautiful, humbling invitation. They call on us to approach the universe not with the arrogance of knowing, but with the wide-eyed awe and curiosity of a child exploring a world where the rules are still being written, and where every new discovery is a doorway to an even deeper mystery. Let's dive deeper into one of the cornerstone paradoxes of the quantum world: wave-particle duality. Imagine you have a friend who is a stern, focused professional at their office, but a wild, playful artist at home. You can experience one side or the other, but never both in the same instant. This is how particles and light behave in the quantum realm. Sometimes, an electron acts like a tiny solid bullet of particle. At other times, it acts like a diffuse, spreading ripple in a pond of waves. It dances between these two identities, and it only reveals one nature at a time, depending on how we choose to observe it. The most elegant and mind-bending demonstration of this is the famous double-slit experiment. Scientists at MIT and around the world have perfected this. If you shoot tiny particles like electrons at a barrier with two slits in it, you'd expect to see two lines on the detector screen behind it, like you are firing tiny paintballs. But that's not what happens. Instead, you get a complex interference pattern, a series of many lines, which is the telltale signature of waves interfering with each other. It's as if each single electron passes through both slits at once as a wave and interferes with itself. But here's the kicker. If you place a detector at the slits to see which one the electron goes through, the wave pattern vanishes and you get the two simple lines you originally expected. The very act of looking forces the electron to choose to be a particle. As if that wasn't playful enough, physicists have discovered something called the quantum Cheshire cat effect, named after the famous cat from Alice in Wonderland. They've managed to separate a photon from its own properties, like its polarization. In a sense, they found the photon in one place and its grin in another. This isn't just a philosophical curiosity. This dance of duality is the engine behind practical advances in quantum imaging, allowing us to see things with incredible precision. And in quantum communication, where information can be encoded in this dual nature, it is a place where science performs feats that feel, for all the world, like pure magic. Now, let's talk about that spinning coin again, the state of being both heads and tails at once. This principle has a name: quantum superposition. It is the idea that a particle can exist in multiple states, or in multiple places, all at the same time in a delicate balance of possibilities. Imagine a musical note that is not just one pitch, but a chord of every possible pitch, all held in shimmering, harmonious potential. Only when you listen, when you measure it, does it resolve into a single clear tone. This isn't just a feature of isolated subatomic particles in a lab. Nature, in its infinite wisdom, has been using this trick for billions of years. Take the process of photosynthesis. A chlorophyll molecule needs to get energy from a captured photon to a reaction center as efficiently as possible. How does it do it? Does it try one path, then another, like a person lost in a maze? No. It uses superposition. The energy exists in a state where it travels along all possible paths simultaneously, instantly finding the most efficient route. It's a natural quantum computer, performing a complex optimization problem in an instant. And this principle is beginning to blur the line between the quantum and the classical worlds we live in. Scientists have successfully placed objects large enough to be seen with the naked eye, like tiny tuning forks made of metal, into a state of superposition. They have made them vibrate and not vibrate at the same time. This is a monumental achievement. It shows that quantum weirdness isn't necessarily confined to the microscopic realm. It's a fundamental principle of reality, a reminder that beneath the solid, definite world we see, there exists a universe of countless possibilities, all held in a delicate, beautiful, and harmonious balance, just waiting for a moment of observation to give them form. Of all the strange behaviors in the quantum zoo, entanglement is perhaps the most profound and mysterious. Einstein famously called it spooky action at a distance, and for good reason. Imagine you have two of those quantum coins we discussed, and you entangle them. This means their fates are now inextricably linked. You can then separate them, sending one to the other side of the room, or even to the other side of the galaxy. The moment you look at your coin and see that it landed on heads, you know, instantly, and with absolute certainty, that the other coin, no matter how far away, has landed on tails. This connection is instantaneous, seemingly faster than the speed of light, which should be impossible according to our classical understanding of the universe. It's as if space and time do not exist between them. For decades, this was a theoretical puzzle. But recently, in a stunning experiment, scientists used a satellite to send entangled photons to two different ground stations over 1,200 kilometers apart. They confirmed that the spooky connection held. The particles communicated their states to each other instantly. This cosmic web of connection isn't just an exotic phenomenon. It's woven into the very fabric of matter. Deep inside the protons and neutrons that make up the atoms in your body, the fundamental particles known as quarks are in a constant state of entanglement. The stability of the very matter you are made of depends on this deep, non-local connection. From developing unhackable quantum communication networks to understanding the fundamental structure of reality, entanglement reveals a universe that is not a collection of separate things, but a single profoundly interconnected whole. It suggests that, on some deep level, everything is woven together in a cosmic tapestry that transcends our limited notions of space and separation. In our everyday lives, we strive for certainty. We want to know exactly where we are and where we're going. But in the quantum realm, the universe enforces a fundamental limit to what we can know. This is the Heisenberg uncertainty principle. It states that you cannot simultaneously know both the precise position and the precise momentum, which is related to its speed and direction of a particle. The more you know about one, the less you know about the other. Think of it like trying to take a picture of a speeding car. If you use a very fast shutter speed, you can freeze its motion and know its exact position, but you have no idea how fast it was going. If you use a slow shutter speed, you get a long blur that tells you about its motion and direction, but you can no longer pinpoint its exact location at any given moment. This isn't a flaw in our measuring instruments. It is an inherent, inescapable property of reality itself. Reality, at its core, is a little bit fuzzy. But here is the beautiful secret of this principle. This uncertainty is not a defect. It is the very reason we exist. If we could know an electron's exact position and momentum, it would spiral into the nucleus of an atom, and matter as we know it would collapse. The fuzziness of its position allows it to exist in a stable cloud or orbital around the nucleus. This uncertainty allows for the quantum tunneling that powers our sun, enabling particles to overcome energy barriers and fuse together, releasing the light and heat that makes life on Earth possible. The uncertainty principle is not a limitation. It is the cosmic breathing room, the space for play, the fundamental feature that allows for the complexity, stability, and glorious unfolding of the universe. It is the silent, constant dance of possibility. The quantum realm is not just a collection of particles. It's a dynamic landscape where matter can arrange itself into exotic and previously unimaginable states. At the University of California, Irvine, scientists exploring a material called hafnium pentatelluride made a startling discovery. By applying powerful magnetic fields, they witnessed the material's electrons and holes spontaneously organizing themselves into a new state of matter, quantum liquid of those excitants we talked about earlier. Imagine a crowd of people in a plaza. Normally, they mill about randomly. But under certain conditions, say, when a certain music plays, they spontaneously form intricate, flowing dance patterns. That's what these electrons were doing. This isn't just a scientific curiosity. This excitonic liquid has incredible properties. It could lead to self-charging electronics that harvest energy from their environment, or technologies that are incredibly resilient to the harsh radiation of space. And this is just one example. Researchers are discovering quantum liquid crystals. where particles flow like a liquid but maintain a degree of order, like a crystal. They are exploring phase transitions in quantum information, akin to water freezing into ice, but for the very fabric of data itself. These discoveries are not just expanding our knowledge. They are reshaping our technological future. They hint at self-repairing materials that can heal themselves at the atomic level, unhackable communication networks secured by the laws of physics, and new forms of energy generation. It's a powerful demonstration of how, by listening to the deep creativity of nature, we are learning to build a future that was once the domain of science fiction. For a long time, the magical weirdness of the quantum world seemed to be a secret kept by the very, very small. It was a club for electrons, photons, and atoms. But what if that's not the case? What if the quantum dance could be performed by things we can actually see? In recent years, scientists have begun to bridge this divide between the microscopic and the macroscopic in breathtaking ways. In one experiment, scientists managed to entangle two silicon beams, each about the width of a human hair. These are objects containing billions upon billions of atoms. In another, they linked the vibrations of two tiny aluminum drumheads, objects nearly visible to the naked eye. They coaxed these tangible, physical objects into a state of perfect quantum harmony, vibrating in a superposition of states, their fates linked by that spooky action at a distance. This is a monumental step. It's like teaching a whole symphony orchestra to move with the spooky, instantaneous connection of two entangled dancers. The implications are staggering. Entangling macroscopic objects could lead to the development of ultra-sensitive sensors, capable of detecting gravitational waves with unprecedented accuracy, or changes in magnetic fields so subtle they could map the firing of neurons in the brain without invasive procedures. It could create vast, unhackable communication networks where the nodes are not single atoms, but tangible devices. We are learning that the rhythms of the quantum world are not confined to a hidden realm. They are all around us, waiting to be heard, and we are just now learning how to coax even the tangible, classical world to dance to their beat. What do you think of when you hear the word vacuum? Most of us picture empty space nothingness. But in the quantum realm, there is no such thing as true emptiness. The quantum vacuum is a seething, bubbling cauldron of energy, where virtual particles pop in and out of existence for fleeting moments. It is a sea of pure potential. For decades, the idea of tapping into this energy was pure fantasy. But the fantasy is becoming a reality. In a groundbreaking experiment, scientists have figured out a way to manipulate these virtual particles. By using exquisitely controlled mirrors and magnetic fields, they've managed to turn these fleeting virtual photons into real photons, effectively extracting light and energy from what was supposedly empty space. It's the ultimate magic trick, pulling a rabbit out of an empty hat, where the hat is the fabric of space-time itself. To put this in perspective, imagine being on a calm ocean. You might think there's no energy there, but a skilled surfer knows that even on a calm day, there are subtle swells and currents. By using their board in just the right way, they can catch a wave and harness its power. This is what physicists are learning to do with the vacuum of space. This breakthrough, while still in its infancy, hints at a revolutionary future for energy. It suggests the possibility of tapping into the limitless, clean energy of the quantum vacuum that permeates the entire universe. It's a glimpse into a future where the very structure of reality could power our world. A future where the line between the impossible and the practical has completely dissolved. We've talked a lot about observation, how looking at a particle forces it to choose a state from a sea of possibilities. This leads to one of the deepest and most unsettling questions in all of physics, the measurement problem. What, exactly, counts as an observation? Does it have to be a physicist with a detector? Or could it be a cat? Or a rock? Or, most tantalizingly, does it require a conscious mind? Does the universe need you to look at it in order to become real? This is where physics and philosophy hold hands. Some theories propose that it is the act of conscious awareness itself that collapses the quantum wave function, turning possibility into actuality. For a long time, this was dismissed because the brain was considered too warm, wet, and messy for delicate quantum effects to survive. But recent experiments are challenging that notion. They are showing that quantum coherence, the state of superposition, can persist in warm, biological environments for much longer than previously thought. This opens the door to the breathtaking idea that consciousness might not just be a product of classical brain chemistry, but might arise from quantum processes occurring within the neurons themselves. It suggests an intimate, participatory relationship between your mind and the universe. If this is true, it means that your awareness is not a passive spectator watching the movie of reality. You are, in a very real sense, the projector. Every thought, every moment of focus could be a subtle act of creation, shaping the quantum foam of existence into the world you experience. While the role of consciousness is still a deep mystery, we now know for a fact that nature is a master quantum engineer. Life has been using quantum mechanics for eons. How does a robin navigate thousands of miles with pinpoint accuracy during migration? It's thought to use a quantum compass in its eyes. A pair of entangled electrons in a protein is affected by the Earth's magnetic field, giving the bird a heads-up display of the planet's magnetic lines. How do you smell the beautiful scent of a rose? The shape of the odor molecule doesn't perfectly fit the receptors in your nose. The leading theory is quantum tunneling. An electron in the receptor tunnels through an energy barrier in the odor molecule, a quantum leap that triggers the nerve impulse for that specific scent. Taking this even further, some theories of consciousness, like the one proposed by Sir Roger Penrose and Stuart Hameroff, suggest that the very seat of our awareness lies in quantum computations happening inside tiny protein structures in our brain cells called microtubules. They propose that these microtubules act as sophisticated quantum computers, taking the vast chaotic stream of sensory information from our eyes, ears, and nerves, and binding it together through quantum entanglement into the single, unified, coherent experience of now that you are having at this very moment. This suggests that life and awareness are not just incidental phenomena in a dead universe. They may be fundamental quantum processes, weaving consciousness into the very fabric of reality itself. Our experience of time is deeply linear. The past is fixed, the present is fleeting, and the future is unknown. But in the quantum realm, time behaves in ways that are far more strange and fluid. There is a concept known as retrocausality, or backwards in time influence. Experiments have suggested that a choice made about how to measure a particle in the future can influence the state of that particle in the past. It's a mind-bending idea. It's as if a particle, traveling on its journey, is somehow aware of the observation that awaits it and adjusts its past behavior accordingly. This doesn't mean you can send a message to your past self to win the lottery, but it does shatter our simple linear understanding of cause and effect. Furthermore, quantum mechanics is giving us new ways to measure time itself. Quantum clocks, using the precise oscillations of atoms in superposition, are now so accurate they can measure the tiny time dilation predicted by Einstein's relativity over a distance of just 1 millimeter. They can detect the way gravity literally warps the flow of time. Some physicists even speculate that time itself is not fundamental, but might be an emergent property of quantum entanglement. The more entangled the universe becomes, the more the arrow of time moves forward. These insights are not just theoretical. They challenge us to rethink our place in the cosmic timeline, revealing a universe where past, present, and future might be far more intertwined than we ever dared to believe. We've journeyed through the strange and beautiful principles of the quantum world. Now, let's see what happens when we harness that strangeness to build a new kind of machine, the quantum computer. Your laptop or phone works with bits, which are either a 0 or a 1. A quantum computer works with qubits. Thanks to superposition, a qubit can be a 0, a 1, or both at the same time. Now, imagine linking these qubits together through entanglement. 2 qubits can hold 4 values at once. 3 qubits can hold 8. A few hundred entangled qubits could hold more values than there are atoms in the known universe. This allows a quantum computer to perform a vast number of calculations simultaneously, dwarfing the power of even the most massive classical supercomputers. What does this mean for us? It means we will be able to solve problems that are currently beyond our reach. We could perfectly simulate molecular interactions to design life-saving drugs in a fraction of the time it takes today. We could create new materials with incredible properties, molecule by molecule. We could optimize global logistics, financial markets, and even complex ecosystems to fight climate change. The quantum computing revolution is not just an incremental step forward. It is a quantum leap in our ability to understand and shape the world around us. It is the moment where we stop just observing the quantum realm and start actively partnering with it, turning science fiction into tangible, world-changing reality. As we build these powerful quantum computers, we are forced to confront an even deeper idea. Perhaps the universe itself is not made of matter and energy, but of something even more fundamental: information. Quantum information is unlike any information we know. It can exist in a superposition of states and be linked non-locally through entanglement. This perspective, known as it from bit, suggests that what we perceive as particles, forces, space, and time might be emergent properties of an underlying quantum informational process. Think of it like a video game. You see a rich, complex world on the screen, but at its most fundamental level, it's all just bits of information, O-self and one-self. What if our universe is similar, but the underlying code is written in qubits? This leads us to the idea of a participatory universe. If reality is fundamentally informational, then consciousness, as the processor and interpreter of information, plays a central role. The universe isn't a static stage on which we are merely actors. It is an interactive, co-creative process. Observation isn't just seeing what's there. It's an act of participation that helps bring what's there into being. This view invites us to see ourselves not as separate from the cosmos, but as essential co-creators in a grand cosmic dance of awareness and existence. Let's take one final, speculative step into the deepest mystery of all. If consciousness is a quantum phenomenon, and if entanglement links the universe together, could it be that individual consciousness is not isolated? Emerging research is beginning to explore the radical idea that consciousness may tap into, or be a part of a universal quantum field, a kind of cosmic awareness that connects all sentient beings. While this is on the frontier of science, the hints are intriguing. Experiments in neuroscience have shown synchronized brain waves between couples in deep meditation or in love, even when they are in separate, shielded rooms. Other controversial, but persistent, studies have suggested that focused human intention can have a small but statistically significant influence on the output of random quantum event generators. This doesn't mean you can change the world with a thought, but it does hint that consciousness might not be entirely confined to the bone of your skull. It suggests your thoughts, your feelings, your awareness might create ripples in a universal field, resonating with the awareness of others and with the cosmos itself. It's the ancient spiritual idea of interconnectedness viewed through the lens of modern physics. It suggests that your individual consciousness is a unique window through which a universal awareness experiences itself, weaving you into the very deepest and most profound mysteries of existence. Our long journey through the quantum realm is drawing to a close for tonight. We began in the quiet of our own spaces and traveled through a universe of spinning coins, ghostly particles, and spooky connections. We have seen that the solid world around us is built on a foundation of shimmering possibility. We've learned that you are not just a collection of atoms. You are a complex dance of quantum phenomena, from the way you see and smell to the very nature of your consciousness. The greatest lesson the quantum world offers us is this: you are not a passive observer in a fixed reality. You are an active participant. The universe is not something that is simply happening to you. It is a story that is happening with you and in some mysterious way through you. Your awareness, your focus, Your questions, they matter. They are part of the cosmic conversation that transforms potential into actual. So, the advice I leave you with tonight is simple. Live with a sense of wonder. Look at a simple leaf and remember the quantum efficiency of photosynthesis happening within it. Feel the warmth of the sun and remember the quantum tunneling that powers its core. Look at a loved one and consider the profound entangled web of connection that binds us all. Embrace the uncertainty of life not as a flaw, but as the space where creativity and free will are born. You are a co-creator in a participatory universe. As we continue to explore these mysteries together, we'll ask even stranger questions. What would happen if gravity, the force that anchors us, simply vanished? How would reality reconfigure itself? But that is a story for another night. For now, I leave you with these questions to ponder. How does knowing you are a participant, not just an observer, change the way you see your role in the world? If you could ask the universe one question about its quantum nature, what would it be? Thank you for sharing this time with me. I wish you a peaceful night's rest, filled with dreams as wondrous as the reality we've explored. If this journey into the heart of reality resonated with you, please consider subscribing to Top Niche Market and joining our community of curious minds. Your presence here helps us continue to explore these grand mysteries together. Until next time.